Hi folks, welcome to Perf Mentor's micro learning session. In today's session, I'll be covering a very interesting and important topic. That's the stubbing solution. I'm going to talk about how to build a very efficient, cost efficient, highly scalable stubbing solution. Before we dive in, let's try to understand what is a stub, where exactly it is used, and who are the players that use the stubbing solution. First, what is a stub? Stub is nothing but a mock service. If you send a request to the mock service, it sends a response back. It doesn't do any intelligent processing or execute business logic. It just sends a response back. Whatever the configured response that we have on the stubbing service, it sends that response back to the request or the person or the system that sent the request to it. So that's a stub. It's a mocking service. Where exactly it is used? So any software that's being built as part of the agile process, it happens in small chunks, right? Small features that develop, then they integrate both those features. That's how the system is being built. So in such cases, testers, automation, functional, or whoever the players are, right, they're expected to test the solution even before the full complete solution is shipped out, right? So in such cases, we have to test that particular feature, imagining that is the integrations are done. So in such cases, we have the stubbing solution which acts like that integration endpoints. That's one scenario where we use it. So the other scenario is, right, even if a product is fully developed, when it comes to the lower environment, test environment, right, pre-prod or any QA environment, the environment will not be connected to third-party system like payment service or the fraud service, right? There's no need. It's a product that is taken care by that particular third party itself. So we don't have to test the third-party service for performance testing, right? Even in few cases, they have to test it for functional testing, but when it comes to performance testing, they don't have to test that third-party services. In such cases, we have to build a stubbing solution. And the key players who use the stubbing solutions are developers, because while they are building the feature that's not fully integrated or which has to be connected with the third-party system, they use stubbing mechanism to validate the solution. Then we have the functional testers and the automation testers who use, again, for the same reason, if it's not fully developed, they use the stubbing solution to complete their testing. Then comes the performance testing, or the performance tester or the performance engineer. In case of performance testing, it's slightly different from the way the developers or the functional testers use, because in case of functional testing or the automation testing, right, they don't want a robust system, right, like which can handle a high volume transaction. For them, it's like they max test like 1 or 2 requests per minute. That's going to be their throughput velocity that they will be testing. But when it comes to performance testing, we need a stub that could respond for a high volume transaction. That's how our stubbing solution should be somewhat different from the functional tester stubbing solution. It should be able to handle high volume transaction, and in some cases, if it is used by multiple performance testing team, where we have multiple stubbing requirement, right, in such cases we also need a highly scalable solution, and we also need a multi-threaded stubbing solution. Okay, so these are the three criteria based on which we have to build a stubbing solution. So in this session, I'm going to give you a high-level view on the 3 types of solution. One is your simple standalone application deployment, which can be set up in your VM, and you can configure the import of file and right away test it. That's at a standalone or a systems level stubbing solution. It's straightforward and simple. The next solution we have is the containerized solution, where you have a load balancer. Underneath we have some different containers, and each container holds all the different types of stubbing service. Again, this can be set up in a single VM or a single machine. Then we have the third type of solution, where we can build a very highly scalable solution which can be scaled horizontally, right? Like the number of VMs you have, scale up that solution as per the number of VMs you have. So in such cases, we have a different set of solutions. So these are the 3 types of solution that we have to build. One of the disadvantage of the solution number 1 is it's single threaded. So at any given time, it will be able to respond to only one single request. So sometimes it becomes a bottleneck when you're testing for a high volume transaction. So that's the disadvantage of using a standalone or a single threaded solution. To address that, yeah, you can have this containerized setup in your same VM that you used for the other solution, right? So only thing is you have to set up the containers. So you have to wrap your stubbing services into that container, and again it has to be connected to the load balancer proxy. The disadvantage of having this is, like, to some extent, yeah, you can have this working. For example, some 200 requests per second or 100 requests per second, it can work. But again, that's dependent on your memory profile, your CPU, all those stuffs. And if your throughput volumes are high, this will not work. And another disadvantage of having this is the high availability. For example, for some reason this particular machine where you have installed the solution is not working, you cannot test it, right? So that's where the third type of solution comes into play, where it is highly available. It can process, it depends on the number of VMs you have. So thousands of TPS it can support based on your scaling profile. So that's the key advantage of a third solution. So first, let's leave the first solution because that's very straightforward solution. You have to install the Mount Bank standalone application, and you have to build the imposter file, and that's it. And you have to get the endpoints and use those endpoints, right? That's a very simple solution. And the second solution, where we have this multi-threaded feature, but again it's limited to a particular VM. In this case, we need three components: HA proxy load balancer, which uses the round robin algorithm or whatever algorithm we want to define. And this also has this beautiful dashboard, which gives us a picture of our containers. So that's another advantage. You can monitor the health of your containers. So that's the advantage of using a HA proxy over other load balancer. Then we have the containers. So you have this Docker desktop. You can install it, and which has its Node.js component. I think you don't need to get into the technicalities now. With the help of the LLM, the Cloud Code, or other code builders, you can easily set up all those things. If you want to build the solution, reach out to me. I'll help you with all the steps using which you can build the highly scalable solution within half a day. So if you do it manually, it takes, I don't know, maybe days, weeks. But with the help of the LLMs, you can build this whole solution within few minutes or hours. So we have this HA proxy load balancer. All the requests will be mapped to the load balancer and will be routed back to one of these 5 containers. It addresses that concern of single threaded. In your standalone application, you have single threaded. Now with this 5 containers, you can have the requests served by 5 containers. So at any given time, 5 requests can be processed. So that's the advantage of using this system. Now coming to the third part of the solution, right? That's the scalable HA multi-bank architecture. In this case, we need multiple VMs. So again, it depends. If you want a HA highly available solution, you need 2 load balancer proxy, or else you can have one proxy, one machine acting as your load balancer. And then we'll have multiple VMs which will act as different containers, right? Different Docker Swarm. This is called a Docker Swarm. We can use Docker Swarm to set this horizontally scalable solution. So each VM we can have 5 containers, and in each container you can deploy all the stub servers, or it depends on how you want to do it. Maybe if you have 5 VMs or 6 VMs, 3 VMs, you can have some half the stubbing services and the other 3 VMs. It's up to you how you want to manage the load profile. But I would say, have all the, if it's like 10-20 stubs, right, it's better to have all wrapped up in each container on all the VMs. So in that way you can get a high volume. It can be used to test a high volume transaction. And currently, let me tell you the business case of why projects need the solution. In the current industry, in the current market, where different companies charge a hell lot of money for building the stubbing solution, but underneath the solution it's going to be the same kind of setup. So it saves a lot of money, even if your stubbing solution is dependent on some custom solution. The other one is, even if you go for a licensed solution like Tosca, again you have to spend money on the licensing cost. But in this case, to build this highly scalable, higher availability solution, you don't need to spend any cost. Maybe, you can cut down the cost. I mean, there is a little bit of cost involved, but that's very, very less infrastructure cost. But yeah, so you can cut down the overall cost of your stubbing solution, from almost 90% of the cost can be cut down. So this will be a very useful solution, and it will be a very cost effective solution. If in case you are working in a project that involves stubbing solution, you can propose the solution and get this done. If you have any queries, please reach out to me. I'm more than happy to address your questions. Thank you so much. Happy learning.